Okay, so we have question 9 here. It's still talking about electrodynamics, and we have a diagram that is given to us. It is a plot of voltage output of a generator. So on your y-axis you have the potential difference V, and on your x-axis you have the time in seconds. Okay, cool. So the one thing that we know that is that this is a generator, so it's a matter of us trying to determine, is it an AC generator or is it a DC generator. We've already spoken extensively about the difference between an AC generator as well as a DC generator. All right, but now looking at our graph, we see that the potential difference after every 10 seconds it changes its direction. So this is a sinusoidal graph. It's telling us something. It's telling us that this is actually an AC generator, as we have already demonstrated how you can actually see the difference between an AC generator as well as a DC generator, all right, in the previous lessons. All right, so now they're asking us that does this generator have split rings or slip rings? So remember from our discussion in the previous lessons, we said that AC generators actually have slip rings, and then DC generators will have split rings. So your answer there is that this thing has slip rings. And then 9.2 is just a matter of looking at our schematic. It's just which one of the diagrams below, A or B, shows the position of the generator's coil at a time 0.1 seconds. So we can go look at our graph at 0.1 seconds. The potential difference is 0, so we'll check here and then use it. So this is the direction of the uniform magnetic field from here to there, and then we can actually see that this at that time the position of the graph is actually, the position of our coil is actually like this. So the answer there is diagram B. And then moving on, where we have question 9.3, we have calculate the root mean square of this generator. Then they send to us a device with a resistance of 40 ohms is now connected to the generator. Now we have to calculate, what is it, the average power delivered by the generator to the device, as well as the maximum current delivered by the generator to this device that we have just connected, which had a value of 40 ohms. So let us try to actually answer questions from 9.3. Actually on lesson 34, where we are doing a previous question paper, question from a previous question paper. Let me just, okay, so in our question we given a sinusoidal graph for the potential difference of a certain AC generator, and this is what it looks like. So on this side we have potential difference, it's measured in volts, and then there the peak value there is 312, and then the minimum value would then be minus 312 volts, right? And then we are given the time. Here we had 0.1, and then here we would have 0.2. Okay, that's fine. So now the first question 9.3 wanted us to calculate, let me see quickly. So question 9.3 wanted us to calculate the root mean square RMS voltage for the generator. So it's just a matter of remembering our equations that we studied in the previous lessons, where we said that VRMS, so the root mean square voltage, is given by Vmax divided by the root of 2. So Vmax, we have agreed that this value 312 volts is actually our Vmax value. That's our peak voltage. So we'll then just substitute 312, all of it divided by the root of 2. And that will give us a value of about 2,2,62 volts. So that is with 3 marks. Equation, substitution, as well as the final answer. All right. So now moving on to question 9.4. So 9.4 says that now what they've done is that they connected a resistance of about, so 9.4, a resistance of about 40 ohms to our generator, and now we have to calculate the average power. Just see the average power delivered by the generator to this device with a resistance of 90 ohms. Again, you have a number of formulas that you can use from the back of your question paper. The one that I picked was, we can use this one because it's just straightforward. So you say P average equals to V squared RMS divided by R. Because I already know what RMS is, I calculated it in the previous equation. I know what the resistance is, and it's just a matter of substitution now. So we say, okay, VRMS, we found it to be 2,262, all of it squared, divided by 40. And this, if you put this in your calculator, it should give you a value of about 1,216,8. Remember, power is measured in watts. So it's an important thing to remember. So now you can see these are quite straightforward questions. They don't require a lot of deliberation. So let me just put this, I'm just gonna remove this here. So now question 9.4.2 says to us that we should calculate the maximum current delivered by 9.4.2 delivered by the generator to this device. So what do we know? Always start with what you know. So in terms of those equations at the back of your question paper, there's an equation that says P average is given by V RMS multiplied by I RMS. So you see where I'm going with this. So I have the average value, which is calculated it. I have VRMS, I can find IRMS, right? So to do that, I can simply divide both sides by VRMS so that I can be left on the one side with IRMS. So divide by VRMS. Okay, so these two will cancel, and then actually your IRMS will actually be P average power, the average power divided by V RMS. Okay, so we know that it was 1216,8 watts divided VRMS value was 222,62. If we put this in a calculator, we're gonna come to a value of about 7,81 amperes. More or less, this is the value that you're supposed to come to. But we don't want to calculate this. We want to calculate Imax. So remember, IRMS, the RMS value for current is given by Imax divided by the root of 2. So I want to make Imax the subject because that's what I'm looking for, right? So it's just a matter of cross multiplication. One times Imax will just give me Imax, and then the root of 2 multiplied by IRMS. So we have, so you can just have the root of 2 multiplied by IRMS. We know what the value of IRMS is. We just found it. It's 7,81 amperes. And then to find Imax, okay, I feel like I made a mistake somewhere and I don't know where. Let me just think quickly. Where did I make a mistake? I made a mistake here. So this value here, so if you have this value, put this in your calculator and you divide it by this value over, so we want PVRMS, what our VRMS was of 220. So this value is actually going to give you 5,52 amperes, right? I hope you guys were able to catch that. It was just a minor mistake that I made. And then yes, to find Imax, it's just a matter of saying it's the root of 2. I've already showed you how to do it. Multiply by IRMS value. So that is the root of 2 multiplied by the value of our IRMS is 5.52, which will then, if you put it in a calculator, will give you 7,81 amperes, right? So that's the value that you're supposed to find. And this is actually brings us to the end of this lesson.